Hello, I'm Rochelle, and I thought I'd let you see me for a moment. This video, we are going to be factoring using grouping. So I need to go to the right screen here. There we are. And one of the ways of factoring is by grouping. It's most commonly used if there are 4 terms in the polynomial. But a reminder that factoring takes something from standard form, which is basically 3 things being added or 4 things being added, and then changing it into a product of 2 things. So this here is a product. So that's why we call it factor, because factors are make up a product. So I've got these steps listed out on how to factor by grouping. So I'm going to go through them and try and color code them as we go. So the first step, every single time, is always going to be factor out the greatest common factor of the entire expression. No matter what type of factoring we are using, we always want to factor out the greatest common factor. And in this case, in this polynomial, there is nothing that is in common with every single term. So in this case, step A is not applicable. Then what we're going to do is we are going to group the first 2 terms and the last 2 terms together. And I just do that really by underlining them. I don't like to use parentheses because I'm going to use parentheses in the next step. And then sometimes that gives me a little bit of a error with the sign in between. So then we're going to do some greatest common factor work, and we're going to look at these first 2 terms. So I'm going to go ahead and color code this, with purple. So I'm going to go ahead and look at the first 2 terms. So I'll go ahead and color code that purple, and we're going to factor out the greatest common factor. So we're going to do that right here. So I want to look here at what is in common. And there's no number in common, but I see that they both have an x squared. So I'm going to factor out the x squared, and I'm going to write what would be left. So x squared times what would give me x cubed? Well, that's just x. I could also think of it as dividing by x squared, and I would still get the x. Then I'm going to have x squared times what will give me plus 5x squared. Well, if I just divide that by x squared, I'm just going to have the 5 left. We can always check this by distributing back through, and we should get what we started with. Then we're going to do the same exact thing. I'm going to go ahead and just leave this as green. Leave this as green. So this was purple. Purple is the first 2 terms. Green is the last 2 terms. So I'm always going to copy my minus down, and then I'm going to try and see what's in common here. So if I look at that, I see that a 4 will go into 4x and 20. So I'm going to write down -4 is what I'm bringing out. So it's like I'm going to divide both of these by -4, or I'm going to ask myself -4 times what? So what should I put here to get -4x? And that answer is just x. -4 times what will give me -20? That answer is 5. Now, if it is factorable by grouping, we should see something really nice. We should see that the things that are in parentheses here are the same. And that's why this right here, this is the greatest common factor of the 2 remaining expressions, because this right here is 1 term because it's a product. And this right here is 1 term because it's also a product. So what I'm doing is I'm going to take out this x. I'll go ahead and write this in red. The x plus 5, which is what is in common with both of these. And I'm going to multiply it out in front. I'm going to have it out in front. And then I'm basically going to take that and I'm going to divide it on both of these and see what's left. And what's left is just the x squared. And if I divide by the x plus 5 here, or I ask myself x plus 5 times what will give me -4x times x plus 5, that's just going to be -4. And that's what it's going to look like to do factor by grouping. Now, in this particular situation, There's more factoring that can be done because this is the difference of perfect squares right here. So I know that this is going to be x plus 2 and x minus 2. Now, I have a whole other video on special factoring. So let's go ahead and practice this a few more times. So again, we're going to factor out the greatest common factor if there is one. So that was step A. That is not applicable. This was step B when we grouped the two together. Then, well, I guess step B was this right here. And then this was step C. I'll go ahead and put this as purple. And this was step D. And then this right here was step E. So again, let's go ahead and try that. I'm taking deep breaths, like, I don't know why. Nothing in common. I'm going to group the first two together and the last two together, and I'm going to see what's in common. Sometimes you might have to rearrange the first two and the last two so you can find something in common, but not here. If I look at these two terms right here, I see that they both share a 5. They don't both share an x, but they do both share a y squared. So I'm going to take that out, and why I'm doing that, not in purple, I don't know. We need to keep things color-coded. And if I divide by that 5y squared, what would be left is just the x. And 5y squared divided by 5y squared here is going to be 1. Sometimes people don't want to write anything because it's like they went away. But there's always going to be a 1 left over. And again, if you FOIL or if you distribute this through, you will get the above answer. That's the nice thing about factoring is at any step, you can multiply things out and you will get the previous step to check and make sure you did it correctly. These last two terms have a 3 and an a in common. So 3a times what will give me 3ax? That would be x. And 3a times what will give me 3a? Again, that's going to be a 1. I know that I did something right because these are the same. So that's going to factor out in front. And what's going to be left are these other guys of the 5y squared plus the 3a. I know that can't be factored anymore because they're all different letters. Let's do that one more time with all x's. God, I was thinking that maybe there was something in common here, but 9 and 8 don't share a factor. So we didn't have to factor out the greatest common factor. Probably should have had an example of that. So we're just going to separate the first two and the last two terms together, and we're going to factor out the greatest common factor. The previous video will tell you how to find that greatest common factor, but here I see that it is 9x. 9x times x will give me 9x squared. 9x times 2 will give me 18. Now, on this second one, remember, we always want to copy the sign down. I did it here. I just didn't mention it because we always need to factor out that negative. I see that 4 and 8 have a 4 in common. Negative 4 times x is going to give me negative 4x, and negative 4 times positive 2 is going to give me negative 8. Once again, I see that x plus 2 in common. And the remainder of what I have left is the 9x minus 4. I don't need to write them in two colors, but I sure can.